want you to all close your eyes. Think of walking into your grandmother's house. There's fresh bread in the oven. You waft the smell of the steamy aroma in the oven. And then think of when the bread finally comes out of the oven, you cut into the first piece, and this eruption of steam comes out, and you look at the bread and it's soft and porous. Remember that smell and remember that taste. You can open your eyes. Bread is an amazing thing, and if you have never thought about it before, at a molecular level, it's even more amazing. Food scientists today have discovered how bread works at a molecular level and have discovered enough about it that we can understand how each ingredient works in the development of bread. As someone who's studying food science themselves here at BYU, I get to study and learn about all different kinds of food and their safety. Today I'm going to be talking about the production of bread and how, at a molecular level, the bonds are formed. First, we'll zoom in on the molecular level and we'll look at how the disulfide bonds are formed and how that contributes to the structure of bread. Then, we'll kind of zoom out and we'll look at how each ingredient in bread plays a role in bread development. And third, we'll look at some necessary changes that might be made regionally or regarding bread flour type. With gluten development, there's two different kinds of proteins in flour. There's gliadin and there's glutenin. Dr. Pike here at BYU, he has a class, Essentials of Food Science, and he says in his class that the gliadin and the glutenin, as they're hydrated, form together, and as you can see here, they form disulfide bonds. The gliadin is responsible for the fluidity and the stickiness of the bread, and the glutenin is responsible for the elasticity. Both of them are really necessary to produce a good structure in the bread. Guy Crosby is a food scientist on the web, and he has a website that talks about all different sorts of food science techniques. And he talks about bread, and he says that the proteins in bread in the flour are initially frozen, and when they're hydrated, they're allowed to be fluid, and that's when they can intermix and form these disulfide bonds. Dr. Park in his class goes on further to say that there's sulfur molecules within the flour, and eventually they find each other, and that's when they create this strong network that allows us to have the structure that we see today, the pores in the bread. Guy Crosby even says that it's like a paper mache balloon. You take a balloon, you mache it over it, and then you let the paper mache dry, and then you pop it, and that same paper mache structure still maintains. That is just exactly how it is with bread. The gluten structure interacts, it forms this network, and then as the air evaporates, it maintains that structure. Now we'll move on to ingredients. Every single ingredient is important in bread. There's your dry ingredients and there's your wet ingredients. With the dry ingredients, as I've already gone over, the flour contains the proteins necessary to have the structure in the bread. Your baking powder or your other leavening agents are important for the rising of the bread, but also producing gases that create that porous structure. Salt and sugar are important for taste, however they differ in their functions. Salt actually will control yeast production, and if you have too much salt, it will inhibit yeast production and it won't rise. Sugar actually is what feeds the yeast. So the more sugar you have, the more that it'll rise. You have your other wet ingredients as well. You have water, and then you have fat, and you have your eggs. Eggs are important for binding. They're an emulsifier, and they bind the ingredients in the bread together. The water is important, as we said before, for hydrating the flour molecules. And the fat is important for the tenderness of the bread and the flakiness of the bread. Lastly, I want to talk about the changes that are necessary for bread, and this is very important for us students here in Utah, because above 3,000 feet, there are certain changes that must be made to bread in order to make it at an optimal fluffiness and tenderness. First, you need to decrease the amount of baking powder because the atmospheric pressure here in Utah is lower, and so it takes less it takes less baking powder to leaven the bread. Also, you need to add more water because there's a lower boiling point as you increase in altitude. So that means that your water is going to boil faster and you're going to have more evaporation. So you're going to need to add more to compensate for that. And lastly, you really need to add more flour because as you add more water, you need to add more flour, and that will increase your structure and help make it more tender and porous. Lastly, I want to talk about the different types of flour that you can use. There's bread flours and there's all-purpose flour, and those contain more protein. They have more gliadin and the gluten that we talked about before. And also, you have, on the other side of that, you have pastry flours and cake flours. Kimberly Massabay at finecooking.com, she goes into different types of flours, and she says that the best use of flour for bread is going to be your bread flour and your all-purpose flour, simply for structure. So anytime you make bread, you want to think about the chemistry of bread and at the molecular level what's going on. Everything is important in food science regarding all the ingredients. They all play a special role in the final production of food. And then I'll pass out bread. And I'll remind students to always think about what they're eating and how it's working on a molecular level.